All right. Welcome, everyone. My apologies for the slightly non-fluid start here, uh, but it's all smooth sailing from this point. The discussion today is electrifying U.S. industry. My name is Blaine Collison. I am the executive director of the Renewable Thermal Collaborative, and I am joined by my colleagues Ali Hasanbeigi, who is the founder and CEO of Global Efficiency Intelligence, and Steve Skarda, who I suspect many of you know. Steve is a global energy CO2 leader at Procter and Gamble. And what we want to do today is talk about electrifying industry from a couple of different perspectives, right? And we have part of what we're going to use as a foundational text is a recent report written by Ali, and then I helped a little bit along with my colleagues Lynn Kirschbaum and David Gardner. I actually am the senior vice president at David Gardner and Associates, and this is a really interesting report, and I will post the link to download the report in the chat once I turn it over to Ali here. But this was designed to be a deep look at both the technical and pragmatic process questions for electrification. So how do we do it? Do we have the technology? What are the greenhouse gas implications? What are the cost implications, right? How do we do this? And then what are the barriers? What are the barriers to doing what's technically possible? And then how do we deal with the barriers? So we convened a multi-stakeholder working group around these questions, and so Steve was part of that effort. We were planning to be joined by Helen Hudson, the head of sustainable manufacturing at Unilever, also, who's part of that effort. She unfortunately could not make it today. But so what we want to do here is have Ali give us a sort of technical baseline and a sense of what's in this report. You'll want to download it and read it cover to cover, I assure you. And then we'll have some discussion sort of back and forth, particularly bringing in Steve's practical and pragmatic perspective. I want to encourage people to submit questions as we go along via the Q&A button here, and we'll try to engage on as many of those and cover as many of those as we can. And also, please introduce yourselves in the chat as we go along. So with that, and again, my apologies for the stumbling start here, but Ali, thank you for joining us from Taiwan today. Tell us what's in this report, because this is a heck of a piece of work.
Thank you, Blaine, for the introduction. Well, hello, everyone. I'm Ali Hasanbeigi from Global Efficiency Intelligence. We are a consulting firm based in the US. Currently, temporarily, I'm in Taiwan for the COVID, actually coming back to US soon. So here is actually the picture of the cover of our report. I highly encourage you to go. It's over 100 pages, so much details are in there that we cannot cover today. I'm given, I think, less than 10 minutes to say a few words about the technical analysis aspect of our study. So without further ado, let's just get into it. When we did this study, we wanted to actually look at how we can electrify heat, and in some cases also electrification of like feedstock for the chemical industry, but the primary focus was electrifying heat in manufacturing. And there are a few studies out there, but they stay at the higher level overall industry. We saw the lack of information or a gap that like detailed subsector level and system and technology level analysis in this. But looking at industry US manufacturing, as this graph shows, you can see about 2/3 of the total energy use is related to thermal processes, process heating, CHP, cogeneration, and conventional boiler together, about 2/3 of energy use. So that's basically the part we need to electrify if we want to electrify the industry. So huge potential just from that point of view. But industries are different in terms of how they use heat. So this graph shows the heat demand profile, for example, for a few industrial subsectors by temperature. When we talk about electrification, some people immediately jump into the conclusion, or it's difficult to electrify, for example, cement industry. But there are many other, which is high temperature. We don't have currently the technology, but we have many other industries that actually they use low temperature or below 100 degrees C, or medium temperature between 100 to 400 degrees C. And relatively speaking, those low medium temperatures are easier to electrify. And of course, for some high temperature sectors like basic metal, which is steel industry primarily, we have electric arc furnace, fully commercial technology. So just again, from that indicator alone, there is a substantial potential from temperature profile in different industrial sector that we could look and have those low hanging fruits, low temperatures kind of tackled for electrification. In that regard, another graph from my colleagues at NREL, this graph shows on the cumulative energy used in US industry and the temperature profile. Easily you can see 2/3 of process heat used in US industry is for processes that use heat below 300 degrees C. For the American audience, that's below 572 degrees Fahrenheit. So again, that's substantial amount of energy at low and medium temperature that we can electrify. So what we did, as I mentioned, we wanted to go like deeper into the subsectors, but also systems and technology level analysis, not just do the top down that some of the other studies have done. So we did the analysis for 13 different industrial subsectors in the US. As you see, they are listed on the right-hand side. And for those 13 sectors, our analysis actually was how to electrify the end use of heat and those end use technology. But in addition to that, we develop a separate scenario that we don't touch the process itself. We go to the boiler room and electrify the boiler. So we develop a separate scenario. What if we just electrify industrial boilers in the US, and we did the analysis for that. For the analysis, we basically looked at the existing heating system in each of those subsectors at the system and technology level, how the heat is used, what's the temperature profile, what's the purpose, like if steam is used, is it for heating, it's for process, whatsoever. And then we, through a range of the electrification technologies that we had, we looked which one is more suitable for this process for that given subsector. And from that, we did the process integration analysis, and based on the data we had both for conventional and electrified technology and processes, we did the calculation for energy use, GHG emission, and cost. I will show you an example of the type of data we collected and the analysis we did and the results we have for one sector as an example. And in the report, you will find results for all the 13 sectors, plus the industrial boiler, as well as fairly detailed explanation actually we have provided on what is the conventional process and what is the electrified process and electrified technology. So you can clearly see that like the shift of technology we are suggesting, what could that look like and what technologies actually we're talking about. This is an example for electrification of container glass industry in the US. Container glass accounts for about half of the glass production in the US, fairly energy intensive, fairly important sector from energy point of view. So we have provided such table for all the industrial subsectors we analyze. I'm gonna explain what kind of data is there. In the middle, if you look, we have different main process steps for production of the container glass in the US, like mixing, melting, etc. On the left-hand side, we have listed the different equipment, primarily kind of heat equipment, that are used, and also the electricity intensity and thermal or fuel intensity for each of those processes. Those are for conventional process steps. the intensities are per ton of product. And then based on our analysis, as I mentioned, we kind of try to match the electrified technologies that can provide those heating for each of these process steps. So when you look at right-hand side, you will see those electrified processes. For example, we have electric glass melter. And actually, this is a fully commercial technology. I talked to a technology provider in the UK during this study. So most of the technologies we covered, actually, they are currently available. And other steps like electric furler and electric annealing. So those are the electric alternative we have considered and also provided the electricity intensity for those. And as you see from the bottom row, when we electrify, you can see the overall energy intensity of the electric process is lower in final energy term is lower than the conventional process. And that was actually one of the relatively surprising finding that for all the sectors we electrified, in final energy term, we saved energy. For CO2, slightly different story I will show you, but the energy reduction was there. So that was the energy per ton of product. Then we had, our analysis calculation based on, for example, how much glass is produced, container glass in the US in 2019 and projections of that. We did the calculation of the total change in kind of final energy use after electrification. The values are negative, indicating reduction of energy use. And as you can see, this is total technical potential, meaning assuming 100% adoption rate. So if we electrify everything tonight or today, we will get significant reduction. Of course, we know in reality the adoption will be gradual, but we just wanted to quantify that total potential. So for energy, we immediately get the benefit of energy saving. But for CO2, a slightly different story. We used for our CO2 analysis the grid emission factor in the US. And the numbers or values are down there, are presented in the small table, and the projections that we have assumed up to 2050 for the US grid average grid emission factor. And as you can see, as a result, in 2019, even though we get the energy saving, we get a slight increase in CO2 emissions as a result of electrification. And that's probably, as you can guess, is because the electricity grid in this case is not decarbonized enough or clean enough. But as we decarbonize the grid, based on the assumption you see in the table, you can see we start getting like the benefits from CO2 front, and with significant reduction in 2050 as we have completely clean grid. So moral of the story, and that was the case for many of the subsectors with the exception of a few. So we need to have clean grid when we electrify at a country level. Of course, at the project level, plant level, you might electrify and you have access to the clean electricity regionally, or at the project level, then you can immediately get the CO2 benefit. But at the country level, with this assumption, that was the case, that currently US grid is not clean enough for complete electrification. For cost, we only looked at the energy cost story, like compared the energy cost per ton of product, in this case, container glass, for the conventional process and electrified process. So what this graph shows you shows the cost, conventional versus electrified process in 2019 and 2050. The y-axis shows cost per ton. The blue color is the natural gas costs, and the orange is the electricity cost. For the conventional process, as you know, we have both natural gas and electricity, and for electrified process, only electricity. You can see clearly electrified process consumed, the cost is almost twice as the conventional process. And actually, almost for all the sector, I would say the electrified process, what energy cost was substantially higher than the conventional process. Again, we know natural gas is pretty damn cheap in the US. Electricity actually is relatively expensive. If you do this analysis, for example, for China or Europe, where natural gas prices are higher, graph could look different. So that's good to keep in mind. And the cost, if you wonder what kind of cost assumption we made, that table in the below the graph shows that we again use the average unit price of electricity for industry in US and projections of that coming from US DOE EIA data. Some of our reviewers argue that, moving forward, like up to 2050, the cost of electricity, clean electricity, could be significantly lower. That's not what DOE telling us, but at least we got a lot of feedback like that. So to deal with that, we added the error bars, which is basically sensitivity analysis showing what if the electricity price dropped by 50%. So if you compare the lower end of the error bar on this graph, you are looking at the cost with electricity instead of 7 cents a kilowatt hour being like 3.5, 3.6 cents a kilowatt hour. And in that case, you can see the lower end of the bar when you compare electrified and conventional process. They're pretty competitive electrified processes, especially in 2050. And also, last thing I want to add in cost, we did not do any analysis with regards to carbon tax or substantial increase in natural gas prices for whatever reason as a result of some climate policy. So if you take that into account, which is very likely, then that blue bar is going to be kind of longer, and that makes conventional process more expensive in terms of energy costs. For the interest of time, I'm going to move forward. So this is a summary of the result for the CO2 in 2050 for all the subsectors that we have analyzed: steel, ammonia, paper, 5 subsectors of food industry, methanol, and aluminum, etc. So we have very detailed, similar result I showed you for container glass industry for all these subsectors in our report, and I will encourage you to look there for more. And if you have any question, I would be happy to answer. Put your question, please, in the chat box, and I'll try my best to address them. And I think after that, we also have a Q&A. Thank you very much. Blaine, back to you.
Yeah, thank you, Ali. I tell you, it is no easy task to condense the depth of the technical insight in this document into 10 minutes. Nice job.
Thank you.
I tried to do it a couple of times, and it truly isn't easy. There's a lot there, and I've been watching the download counter click by as we've been having the discussion here, and 15 or 20 of you have already come and grabbed the report, and that's great. This is designed to be out in the hands of the world, right? There's some really important conversations here, and before I invite Steve to provide some of that insight from the practitioner's perspective, and by the way, keep the questions coming. Let me provide go back half a step and provide a little bit of context for the RTC and this work, right? The Renewable Thermal Collaborative is an initiative co-convened by David Gardner and Associates, where I work, by the World Wildlife Fund, and by the Center for Climate and Energy Solutions. And we are working with an ever-growing group of global industrials, particularly in the manufacturing sectors, and some North American institutional energy users, digging into thermal, right? I mean, in a lot of ways, the task of decarbonizing thermal emissions is what's next. We collectively have done some remarkable work on renewable electricity, right? It's where I've spent the previous, 15 years of my career. But there's been a massive transition, right? And we're starting to electrify transportation. The IEA report that came out last week says that we basically have about 2.5 more minutes to really get engaged on decarbonization. And industry, I think, in a lot of ways is the big glaring challenge, right? And there's a lot of talk about electrification as a solution, right? It's one of the solution pathways, particularly for industrial applications, that really offers some scale, which makes it pretty interesting. But there are some challenges, right? And that's a bunch of what this report is designed to highlight. Both the technical, pragmatic, down in the process possibilities and sort of the mapping of those processes, and then how do we get from here to there? So, Steve, with that as a setup, you've certainly been thinking about these issues as much as anybody in the space over these last couple of years, and I'd love to get your reaction to these questions, what we've heard so far today, and sort of how you and your peers are thinking about electrification.
Yeah, thank you, Blaine. Thanks for the opportunity to talk to this group. Building on what you said, back in 2010, we had this goal that we said we're going to use 30%. And we just had no idea how we were going to do that. About 2/3 to 3/4 of our total energy consumption is actually natural gas. And so we realized at that time, right off the bat, even if we got to 100% renewable electricity in the decade, we still weren't going to hit our goal. And to your point, a lot of remarkable things happened over the decade. One of those big ones is a lot of collaboration. There's a Renewable Energy Buyers Alliance where we got to partner with suppliers and our peers and regulators and utilities and really led by a couple of really great NGOs. And we made a remarkable progress. So today, we did it. We didn't know how we were going to do it, but today we're 30% renewable energy. One big chunk of that was a large thermal project that we did in Georgia, Albany, Georgia. But we also have 100% renewable electricity in the US and Europe, and all of that has driven value for our business. So it's all been really good value to us that we've been making that progress, and we've done great. But what's still really out there is this thermal energy, right? Yes, I said we have one large project. It was a great win for us. Knocked out 10% of our total energy consumption in one project, but that was pretty unique. We are now really looking to how we've reduced our absolute emissions 50% through all that renewable electricity in that large thermal project, but the remaining emissions that we still have out there are all from natural gas. So how do we tackle that? And we're spending a lot of time really strategizing and putting together roadmaps, innovation roadmaps, and really starting to lead some pilots, really starting to figure out how are we going to tackle this challenge? How are we going to decarbonize the rest of our natural gas? And it is a huge challenge, of course. So, we think of it in three buckets. There is which honestly is actually, I think, the first, of course, efficiency is always the first thing we work on. And can we do a better job of using less heat and capturing more of our waste heat? But then really close second after that, in terms of the most desirable option for decarbonizing to the next is right there is electrification. Especially as we start to think heat pumps and how do we do that? There are also, of course, we're looking at things like renewable fuels and even starting to think about things like carbon capture and what can that have. But right now, if I just said, what is the thing that I am most looking to drive value in the short term and decarbonize in the next step, it is electrification. But there's for sure some barriers. I mean, there's technical barriers for us. It's whenever we've designed a process for the last, many decades, it was always the process engineer always said, well, I get all this heat, all this steam, right? Today, how are our plants built? We put a little boiler and we put steam everywhere, high pressure steam. And so if I need heat, whether it's hot water or no matter what, I throw in a heat exchanger and I take this unlimited steam and it turns into hot water. And it's causing us to really rethink that process. I mean, should we be thinking more about hot water loops rather than steam distribution? Can that help us do a better job of capturing waste heat? Can it help us enable more use of heat pumps? Because we do a lot of heat pumps for building HVAC, but we don't do a lot of them in our processes. So that's where we're working right now. And then there's, I guess I could talk also about all the other barriers that are out there that we didn't have with electricity that we still face with thermal energy, accounting practices and what are RECs and regulatory support and all of those other things that the RTC is working on. But first and foremost right now, we really are, it's efficiency and then electrification is the next one after that we're really trying to tackle. And how can we do it in a way that drives value for our business, just like renewable electricity did? And it's tough for sure.
So one of the things that comes up, and I had a lovely slide on this, but I've managed to outsmart myself with Hopin everyone, so apologies again. But as we talked to the practitioners, right, about the challenges to electrification, we heard about questions of technology, right? I mean, Steve, you said you're using heat pumps for buildings, less so in the process piece of the operation, right? And we heard that a lot, right? I mean, say, can I get a really big industrial heat? And where do I get that? I don't know who to call for that. There was some discussion of the need to talk to the electric utility, right? And maybe upgrading the connection from the plant to the grid at the fence line. There's some knowledge and education barriers, but hey, I mean, the things that seem to draw the most attention were these questions of technology, of the cost, right? Of putting in new equipment, of switching to what is probably a higher cost fuel. And Ali, you had an illustration there, looking at the forward view of cost, financing, and of course policy. We're going to wind up talking about policy today, right? We start to think about solutions, right? How do we start to change some of these equations and address some of these barriers? We wind up at policy pretty quickly. But so I think I just melded 8 or 9 questions together. Let me sort of dive down on one that's come in. I'd be interested in both of your perspectives on this, right? We've had we've had questions about how big a barrier is cost and complexity, right? And then a similar question, I think, asking about the scalability, right? And so how, if we're going to electrify industry, how much of this is a sector specific, sort of bespoke kind of effort versus how much of this is broadly applicable? So I think there are a couple technology questions in there and a couple of barrier questions. And Ali, let me give you first crack at that, particularly from the process perspective.
Sure. Thank you, Blaine. I was just slowly trying to answer those in chat box, but for the audience. Actually, the technologies are quite as scalable and replicable. Like once the technology is available for a given process for a given sector, for most sectors, there is not huge variation across plans for a given process. Of course, certain industries are more complex than the other. For example, if you go to chemical plants, which are more highly integrated, the whole heat and things like that, very complex. If you want to just electrify a piece of the process, you have more challenge. It's doable, but more plant-specific context and considerations, need to be have. But if you go and want to electrify, for example, simple food processing plant with low temperature, where you can, for example, put a heat pump, could be more straightforward and more replicable. And when you talk about boilers, actually much more kind of a straightforward. So, but overall, from all the sectors, I would say huge amount of potential is quite scalable. As I said, technologies are available and then replicable. But there are some sectors and some processes that could have variation across brand because of integration. Quick on the cost and complexity. I think I mentioned the cost. One thing to highlight for the cost, it was out of the scope of our study to look at the capital cost and other costs. But we only looked at the energy cost, but you have to look at the capital cost or life cycle costs and things like that to have a full grasp. Change in the operation and maintenance costs. Also, electrified technology can provide many co-benefits, better control of the process, possibly better, lower maintenance costs, higher production rate, and things like that. So once you can quantify those, and often from energy efficiency also experience, we know a lot of industrial plants, they go do the energy efficient and just install energy efficient technology, not necessarily because of the energy benefit, because of all the other benefits. So same here. So there are other benefits that we see the need for being quantified and taken into account in the cost and technical analysis. On the utility side, I think the question is specifically asking, we didn't look at, but there is a need. When once we electrify, we have this huge demand for electricity. Utilities need to take care of that. We had good number of recommendations in our action plan, but we didn't do like analysis on the grid side and things that need to happen.
And
Steve?
Yeah, Steve, from the practitioner, I mean, you're sitting there thinking about a facilities portfolio, right? So questions of scale and process engineering and engagement with the electric providers, right? Those have all got to be floating around a little bit.
Yeah, absolutely. I mean, and for sure, our leadership is one of the first expectations they share with us is we develop solutions and modular, so we can, once we start to pick a design, we can start to picking it up every place. And there's part of me that thinks, well, yeah, maybe that'll work. I mean, I guess I can put hot water loops in, and I could think about a central plant that's based on heat pumps rather than electric boilers, or maybe some electric boilers, and that could be scalable. But then there's another part of me that thinks about practicality of, we do a pretty good job in P&G of standardizing our manufacturing processes, but not necessarily our plants. And I don't mean we don't do a good job of that. It's just not a business need. We have a different mix of products that are needed in each different region. And so no two of our manufacturing sites look different. And so as I think about how do you, if you're really going to drive value with something like heat pumps, ideally you're going to want to find these sources of waste heat and some places you're doing some cooling. And if I'm doing cooling here and I have some waste heat, that's like a perfect place to start pulling some heat from one place to another. Or if I either have waste heat or cooling, and that's where you can really start to get better value than just I put in some kind of central heating. So all of a sudden the scalability becomes a lot more challenging for us. And then there's this always the people that like ask the obvious question, which is like, hey, Steve, why don't you just do a little math on the amount of natural gas that you're bringing into that site right now, convert that into megawatts of electricity, and then think about how big your power lines need to be. And really practically, where can your power plants, and I know this is a US conversation, but this happens much so even so outside of the US, can your local utilities even get you that much power? And it starts to become a little overwhelming if you don't take it over in little bite-sized chunks. But scalability is for sure one of the really big questions and things that we need to be solving for as much as possible.
Well, and does that suggest, Steve, and we have a question starting to explore this a little bit. Is there a role for industrials that are looking at electrification as a go forward strategy to sit down with their electricity suppliers and say, look, well, welcome to our really big plant, right? We're trying to go over the hill here on climate. It's a big lift. We're going to need more product, more power. Let's have a conversation here about what the 5-year scale up looks like, because we're going to be turning to your distribution network, and if we're going to do this, we're going to need things to come through the wires, and we're going to need appropriate tariffs, right?
We need enough renewable electricity as well, right? I mean, part of me also just worries that if I throw so much stuff on the renewable electricity, am I really using those what today are limited renewable electricity resources responsibly? Because there's just such a huge energy load there. We're not at the point yet within P&G where we're starting to call up our utility and say, we need you to run some more transmission lines to our plant. But I do see the conversation potentially heading in that conversation at some point. Now, is that in the next year, or is that 5 or 10 years out? That's what we're trying to figure out right now, is really how quickly, where are the places that we can go quickly to start doing some electrification, and then where do we see the right mix of options, and what does that roadmap and innovation look like long term, so we can start thinking about the harder questions around infrastructure and what do we have in place and what don't we. But we're not quite there yet, but that is for sure where the conversation is going to be going, some of it.
I'm reminded that we at the RTC we did a webinar about this report a couple months ago, and we had one of our members, Stanley Black & Decker, joined the call, and in fact that I may actually be thinking about the policy call, but one one of the things that Stanley Black & Decker has said is, hey, look, we, like a lot of companies, we've got public goals in this space, right? We are committed to decarbonization. We've put ourselves out. We put a timeline on this. We continue to run into the cost barrier, right? Natural gas, particularly in the U.S., does not cost very much, and it's a challenge. It's an internal challenge to have the discussion about replacing a lot of equipment and switching to a higher price fuel. And there's been a lot of talk here in the first few months of the Biden administration and Congress about some of the policy mechanisms that might be useful in this space, right? And there are bills being worked on industrial policy and looking at some decarbonization technologies. I'm circling around to note again the importance of policy, and in fact the critically important role policy has played in the renewable electricity transition, right? The PTC and the ITC and the various state RPSs have all been bedrock elements of growing and accelerating those markets and achieving scale and achieving cost reduction. That's an important piece to keep an eye on. Ali, at the outset, you noted the opportunity that exists, particularly in the low to medium temperature part of the industrial heat requirement spectrum. We did have a question about what's needed to overcome some of the high temperature process requirements. And I think that's worth a couple moments of discussion, right? Because a lot of this conversation tends to go to, well, what do we do about cement, concrete, steel, chemicals, right? Big chunks of emissions, and we got to figure out what to do there.
Yeah, thank you. So I saw in the comment mentioned that higher temperatures that heat pumps cannot meet. So what do we do about that? So one thing to clarify, for these 13 sectors that we analyzed and the detailed table I showed you for all of them, and to electrify the end use, we looked at maybe more than 10, 15 types of electrification technology. So heat pump is one of the electrified technologies. We have all these other, arrays of technology, whether it's microwave, radio frequency dryer, resistant heating, conduction, etc. So you should definitely look across all electrification technology, and then you will have more options. And that's what we have done. That was a big part of the analysis, finding the suitable electrified technology to provide that heat given the heat temperature, and heat profile of the process. So that's first. But let's say, we look at that and still we don't have it. Like cement is a good example. We don't have electrified technology. I mean, for steel, fortunately, we have, and for glass, I just showed you we have. Although for like flat glass, because high quality is needed, still we don't have fully commercial. There's some work being done there. That comes to R&D, and that R&D, public-private partnership, DOE certainly should to support more of these R&Ds. I would believe like ARPA-E programs and things like programs like that. For cement industry, it's going to be challenging, and honestly, in some sectors, may not be the best solution. It needs to be combined with other solutions, especially cement. As you know, about 50 to 60% of CO2 emissions from cement industry has nothing to do with energy use. It's from the chemical reaction calcination process. So even if you electrify the kiln and use 100% renewable electricity, you're only addressing 40% of emission. So you may want to look at, the situation based on that. And cement is quite unique, actually, situation, but that's where we are. And even for that, there are technologies, actually, we have looked into this, like you can electrify like pre-calciner. Maybe I'm getting too much into detail, but there is technology being investigated. You can electrify the pre-calciner where 80% of emissions coming from, 60% of energy is used, and through electrified indirect heating. And because it's electrified heating, so if you have renewable electricity, you eliminate the energy-related emissions. And then because it's indirect heating, you don't mix with the process-related emission. As a result, you have fairly pure CO2, which is much easier and much to capture at much lower cost. So what I'm trying to say, you can have this electrified technology as a solution to also help with your CO2 capture, which is needed for cement to address that 60% emissions. So, but R&D is needed there. These are kind of emerging technologies that are being investigated. So there is a role for R&D. We have identified in our report as action plans, both for governments and private sector, where they have to definitely spend attention.
And Steve, as we power toward the end of our conversation today, you noted earlier that Procter and Gamble's looking for opportunities to get started, right, and to start digging in and creating some additional engagement and progress. As you and your peers are thinking about electrification, what are you either seeing in the next year or really hoping for in the next year, right? If you could turn to the market and say, you know what, I need 3 things, or even 2 things. I've got 123 people listening. Here's your chance to state the ask a little bit.
Well, I'm still trying to figure out what the ask is, so I don't have a perfect answer for that. I think the thing that surprised me when we started this process was how little we actually know about some of this, or how, I mean, we're just at the very early part of our learning curve, so like I'm starting to build a little bit of roadmap of the studies we need to do, but like heat pumps as an example, I have someone that owns the technology now, and I asked her to go out and like talk to all of our experts, all of our thermal engineer experts in the company, and get the very best information you possibly could find on heat pumps. And there wasn't much out there. We just haven't been doing much of that work. And so we are definitely, so I guess this gets to an ask. We are definitely starting to partner with companies that can really accelerate how we think and learn about how to do this work inside of a manufacturing process. So experts in applying heat pumps, on doing pinch analysis, on doing really helping us quantify all of our heat sinks and our where we're using cold water, and then be able to do that thermal mass balance to really help us figure all of that out and figure out a way to do that. I mean, to me, when I think about all those things, I think, holy cow, that's a lot of thermal engineering work that needs to get done. And so yeah, trying to think about how do we develop a methodology that allows us to kind of start pushing through sites and actually start to come up with some sort of high-level recommendations without having to go do that full thermal engineering study at 130 manufacturing sites. How can we maybe look at a handful of processes that are our biggest processes and apply that? Beyond that, that question around high temperature needs, like I do not have an answer for that right now, especially in the thermal areas. We'll take some of our processes, like maybe dry laundry, and we can think about how do we go from using hot air to, and we already have some answers around how can we use things other than hot air. But like paper making, holy cow, we use just tons of thermal energy to take water out of paper, both hot air and high pressure steam. And it's really hard to wrap my mind around the idea of turning that to electricity. And I don't think I'm there yet. So it seems like a big ask to say, well, do we have technology in that area? But I guess if I could ask for anything in the world, it would be help me figure out how to electrify those really high temperature needs, because that's a big one. That's a big challenge.
Perfect. To anyone that has any of those answers, I can assure you'll find a very interested set of stakeholders at the Renewable Thermal Collaborative. Right. This is we've got as I say, a growing cohort of big industrial and institutional energy buyers who are trying to think through these issues, identify solutions, and get down this pathway. So I notice that we have driven past time by a couple of minutes. Thank you everyone for sticking with us. There is a feedback survey link that Ellie has posted in the chat, and it's pinned there. Please, we would love your feedback. It's incredibly helpful to have, and I thank you all for sticking with us. Ali, Steve, thank you both. This is not the first time we've done this together, but I tell you, I come away each time having learned a little bit more, and this is a really important area of work, and I look forward to continuing it, all of us together.
Thank you.
All right, everybody. Thanks for joining us. Have a great rest of Verge Electrified. The agenda is unbelievable. I hope to see a bunch of you in additional sessions. Have a great rest of the day.
Thank you.
Bye.